So I want to take a quick second to review factoring by substitution. And the first thing to realize is that factoring by substitution we would only use when a does not equal 1. Our whole goal in factoring by substitution is to use a mathematical trick to rewrite the equation so that it looks like a equals 1. And then we would use our normal factoring strategies once we've rewritten it. So you would only use this method when a doesn't equal 1. So let's look at an example. If I have 4x squared plus 12x plus 5, I know strategies to do this, but substitution is just one more that we could use. So our trick is, if we want to rewrite it to look like a equals 1, I need this first term to be a perfect square. And it needs to reappear. So what I'm going to do is multiply this entire expression by 4. Multiply it all by the coefficient of the first term. And then what I would have is 4 times 4x squared plus 4 times 12x plus 4 times 5. And I'm going to take a quick second to rewrite this slightly to show why we're doing that. I can rewrite this as 4x times 4x plus 12 times 4x plus 20. And hopefully this helps you realize why I would have done this, because now you see that there's a term squared plus a product of that term and then a constant at the end. To make it even more obvious, I am going to let p replace 4x everywhere in here. So then I could rewrite that whole problem as p times p plus 12 times p plus 20, which of course you would more frequently see as p squared plus 12p plus 20. At this point, we have a quadratic trinomial with a coefficient of a equals 1. By multiplying by this a, I've forced my problem to look like one of these simple factoring trinomials we've been working on. So I would look for something where the two factors of 20 add to 12, and I could find p plus 10 times p plus 2. Checking that out, I'd get p squared plus 2p plus 10p plus 20, which goes back to here. So this gives me a chance to factor it using that simple strategy. But, of course, I don't want p. P really is 4x. So I'm going to go back and replace that, and I have 4x plus 10 times 4x plus 2. If I went through and multiplied this, I would get 16x squared plus 48x plus 20, which is what I actually factored at this point right here. But it's not my original problem. At the very beginning, my first step was to multiply by 4. I did that for a purpose, but my final answer, I have to remove that. So if I multiplied by 4, to undo that, I have to divide by 4. But you remember that dividing by 4 is the same as multiplying by 1/4. So if I go through, I can then distribute this 1/4, and I can say 1/2, and this is just a trick because this problem is it's just a simpler way to make it neater. I'm going to multiply 1/2 times 1/2 gives me 1/4, and by writing it out that way, I see 2x plus 5 times 2x plus 1. This way I have no fractions in my problem. So this was just one method to solve this way. I can look at another problem and do the same thing. 2x squared plus 5x minus 3. I'm going to multiply, I'm going to do that same trick. I'm going to multiply the whole thing by 2 to force a perfect square in my first term. So I would end up with 2x, quantity squared after doing that, plus 5 times 2x minus 6. I'm going to go ahead and substitute for my 2x that I have forced, and I could rewrite this whole problem as p squared plus 5p minus 6. This I can factor as p plus 6 times p minus 1. Remembering I don't want p, I need to replace that again with the 2x. But here I multiplied by 2, so to finish my problem out, I have to divide by 2. Remembering that I only have to multiply through in one place to get this all done. 1/2 times 2x gives me x, 1/2 times 6 gives me 3. And my final answer is x plus 3 times 2x minus 1. To multiply and check, I would get 2x squared minus x plus 6x minus 3. Which does give me my correct original equation, 2x squared plus 5x minus 3. So this is my final answer. And then I showed you a trick called the slide and divide method, which really takes the same steps and just makes it very algorithmic. I multiply the first and the last numbers, so the 2 times the 3 gives me this 6. And then I factor and divide. It's kind of skipping through the nuance of this substitution, but effectively doing the same thing. So if I slide and divide, my first step would be to take this 2 and slide it down to the end, and I would rewrite it as x squared plus 5x minus 6, which you might recognize as this expression right here, p squared plus 5p minus 6. I've effectively done the same thing. I can then factor that expression, x plus 6 times x minus 1. But I still have to undo this kind of cheating multiplication here. So I'm going to go through and divide both of these terms by the 2 that I multiplied in here. So I get x plus 3 times x minus 1/2. And then I don't want these fractions in the denominator. So I am going to move that fraction to the front of this. So this is 3 over 1. So if I multiply by 1, I still have x plus 3. This is a 2. So I multiply by 2 and I get 2x minus 1. And you see I end up in the same place. This is the conceptual understanding of y, and this is just the shortcut method. Hopefully that will help explain the steps that were written out. If you have any questions, you can review it.